Alright, this is another example of how to do a line integral. So we have our line integral here in this form, which we can't readily evaluate, so we need to put it into this form here, and to do that we need the magnitude of r prime, and we need to find r prime. T. So we just take the derivative of our function here, and we get cosine of t I hat minus sine of t j hat and plus 8k hat. And then we need to take the magnitude of that, basically using the distance formula. R prime of t is equal to square root, and we have cosine squared plus sine squared plus 64. And that's 1 plus 64, or the square root of 65. And then we need to put it into this form and integrate it. So our bounds are from 0 to pi over 2. Those come from our parametric function. And this x, y, z stuff we need in terms of t, and we get that from our same curve. So sine squared t is the x squared plus cosine squared t is the y squared, and the z squared is 64t squared. And then we just have the square root of 65 as our magnitude of r prime and dt. This is almost manageable, so let's simplify it a little bit. 0 to pi over 2. Sine squared plus cosine squared again is 1. 1 plus 64t squared. Square root of 65 can go out front. Just make this a little bit neater. I'll put a line there. And our dt still remains. Alright, so this, we leave the square root of 65. We're going to integrate this, so t plus 64 over 3, t cubed, evaluated from 0 and pi over 2. That's not too hard, 65. We just plug it in and the 0 part's going to go away. So we have pi over 2 plus 64 over 3. And we have the 8 on the bottom. And up top we have pi cubed. And this will take out, factor out an 8. So, and then we'll make a common denominator. 65, 3 pi over 6. And here 16 pi over 6, or pi squared. Oh, pi cubed over 6. And then we can factor out a pi over 6 common in both of them. 65 pi over 6 times 3 plus 16 pi squared. Alright, and we have the answer to our line integral. Thank you, and let me know in the comments what you want to see next.